Alright, it is Friday once again, so it is time for another stream of Odinmade Hero. This programming series I've started where I essentially just copy Handmade Hero by Casey Muratori, but I do it in the Odin programming language. Today we're going to cover days 88 and 89. I guess at one point I was doing this one day at a time, but now we're on 2 days at a time, just because so far, since switching to the new format, there hasn't been like a really tough week, or a tough day, I should say, where I felt like it needed a whole week and a whole stream dedicated to it alone. Things have been kind of going together in pairs, and as soon as that changes, as soon as I come across a day, I think there's one in the hundreds, in the early 100s, where it's like there's probably like a 2 or a 3 hour stream that Casey does. So that one I'll probably dedicate to its own stream. But for now, we'll just keep going like we have been. So push buffer rendering. This was like the very beginning of finally switching into doing some rendering stuff, which I've been talking about for a while. And Casey got to this point where he could feel all of this friction in the code, having to make changes to do all of that work with the ground buffers and splatting the ground buffers everywhere. I should probably make sure that I'm on the right commit. So let's switch to here so we can see exactly what things look like where we left off. Of course, I'm going to lose my notes, but that's okay. We can get them back in a second. So where we left off, we had finally gotten our ground chunks kind of splatting seamlessly throughout the game world. And we do have a seam. We do have one seam here in this corner, which I think that must be the origin, which would explain why things are messed up. But I would think, yeah, on the other side there, it's got to be, that's like where the world coordinates flip into the negative. And so that just could be part of why, like the world chunk, that's like world chunk X -1, you know, world chunk Y -1, that sort of thing. Like I think that could be explaining that. But if we go off in this direction where we can actually move, we can see that the textures just kind of auto-populate in. Because as we're moving around, we're, what does Casey say? He says we evict ground textures and populate new ones to keep drawing in the game world. So, but switching over into the rendering stuff meant that we had to introduce, what is it? I should probably go ahead and, oh no, I messed this up. Let's go back to, yeah, here we go. So let's go to the end of day 88 so I can have my notes back. And we can talk about how we have this new file called rendergroup.odin, which is where all of the things that we're doing, rendering things in the main game code, right, over here, now get moved into that render group file, same way Casey does it. I do have this note in here about a room generation code, which only showed up when I started adding levels back in, where you could travel up the staircase or the ramp, whatever you want to call it. And I think that would have been right here. Yeah, so for some reason this was just written wrong. In fact, if I go back to that other commit, I can probably see it. Yeah, for some reason it was getting a random integer between 0 and whatever this is, which I think is like 1 million or 10 million or something like that. And then it was then bouncing back either 2 or 3 for the door direction and messing everything up, so that there would pretty much always be a door up top, if I'm reading this right. And so by trying to do that, it was actually breaking my game. So it took me a solid, it kind of has nothing to do with everything else we're going to talk about today, but it just goes to show that a small oopsie in my code screwed me over and cost me some time. But it wasn't that bad. It was probably like 10 minutes of just looking at it and wondering what I screwed up before I saw, you know what, this, because I could tell it was the room generation stuff, because it happened, the bug happened as soon as I tried to reintroduce, you know, moving up and down stairs, right? And so that was the tell that it had to be after making that change. It was like one of the first changes, I think, that Casey makes in day 88. So long story short, we're all good to go. But another thing, and I think I called this out at the time because I still would have been doing the series kind of live while following Casey, is that we introduced this test position in, I think, the sim region code to use during collisions, and then we didn't use it. Like, it gets created here, and then I think before today it was just tossed aside like that. But Casey always meant to, I suppose, pass it into the speculative collide procedure, where it then gets used to get the entity ground point, right? Whereas before, I'm pretty sure it was just using the region .p, which is just, this is the entity that the entity that's moving is moving into, or that we're speculating it could collide with as it's moving into that entity. I think I can actually confirm that again by going back here, speculative collide. Yeah, you can see, oh no, get entity ground point only took one parameter, so it didn't take the region. But it literally just gets the position off of the entity, which seems pointless, right? Like, what is the point of that? So passing in that test P actually means that this is doing something, because if that's all that does, right, then you might as well just say that this is the entity's position. Anyway, it's a little bit too much minutia, especially since it has, again, nothing to do with the rendering stuff really. But Casey finishes that, and I think after that, I do have this note about that texture seam in the bottom left, but it's after that that Casey starts pulling in all that stuff into rendergroup.odin. So if I go over there, you can see that this, I think Casey calls it an entity visible piece. I just call it an entity piece, but that's moved in here. I can't remember if we had this render group thing before. I'm guessing we didn't. It might have been called a piece group before. I think that's what it was. Yeah. And then we have this new allocate render group procedure, a push render element call, and then some more familiar stuff where we're pushing pieces and bitmaps and rectangles onto the render group, which was formerly a piece group. And I think I was calling it a render group at one point, because that was like, just somehow intuitively, even though I didn't actually remember that he would rename it to a render group, like, that's how I was thinking of it as. You're taking all this stuff that you want to draw, right, and throwing it into a group of things that you want to render. Hence, it's a render group, right? So that just made sense to me. But now that we have a proper render group, it's fun. We get to get into doing some actual more thinking formally about what the render is supposed to do and how it's supposed to work, which will lead into this conversation about how Casey does it and then the way that I chose to do it. But I want to make sure that I don't skip over anything here. So yeah, we have this idea of a render group, which contains a push buffer where we're pushing everything into it, and it's a buffer of render entities, or render, what does he call them? Render entries or render elements. Pretty sure he settles on entries. We push a bunch of render entries that we want to store to later actually draw to our frame buffer. Actually, I think we draw them to a bitmap first and then draw that to the frame buffer. But it's so that we can sort things and have things like flipping the Y direction, right? Because there's all these places where we're negating Y to get things to draw in the right order so that they're not upside down. We're also doing some scaling, like the whole meters to pixels and pixels to meters, going back and forth. So we want all of those things to be isolated to one place so that the rest of the game code does not need to deal with that. Now, another thing that Casey does is create a new temporary memory thing to then have to then free later for specifically the render memory. I think last time I talked about how we did this for the sim memory, and I think I just call it a sim arena because he has a begin temporary memory call, but what we have with Odin, right, is this begin a temporary arena procedure call. But again, it feels kind of redundant, and if I remove this code, I'm pretty sure nothing changes. I don't think we'll run out of memory, right? It's just explicitly saying, I suppose, that here is where we want to create a temporary arena. It kind of just feels like I should just have one call to begin a temporary arena and have it be temp arena like this, right? That's how I feel about it, because we don't do anything with this thing other than defer the call to end it later on. But anyway, now we have another one of those up here, and I only do one check call, right? Because they're all beginning temporary memory off of the same arena. So I'm doing it as a formality, but I wish I knew enough about what I was doing to be able to tell whether having both of these calls in here to create separate temporary memory arenas, right? I wish I knew enough to know whether that redundancy is actually necessary or not. I mean, if it's redundant, then it's not necessary. Is it redundant or is it not? Is it actually necessary? It just seems to confuse the matter to me. It seems like wherever we want that temporary memory to begin, we just want to make sure that we end it at the very end of everything. So maybe that's the difference, actually, now that I think about it a little bit more. If we want the temporary memory, let's say we wanted some section of temporary memory to end partially down, some way down this call here. Let's say we got here, and then we wanted to do some more permanent allocation to the transient storage, which seems like, counterintuitive because it's supposed to be transient. But anyway, let's say we wanted to do something permanent here for whatever reason, and then we wanted to begin a new temporary memory section partially down somewhere else. In which case, we wouldn't want to defer these calls, right? We wouldn't want to defer the end to those temporary arenas because then they would end after we did want to create something that's semi-permanent in here. And another thing I just thought of, keep bouncing all over the place here, but maybe it's transient because sometimes we update those ground buffers, right? That's something that I talked about a little bit last time, where I think in day 87, Casey added this executable reloaded member to the game input. And that's what makes it transient, because if the executable reloads, then we want to make sure that we redraw the ground buffers so that if any code change happened to that, to the way ground buffers are being drawn, we want to reflect that when the game DLL is remade. So yeah, I can kind of understand now why that should go in the transient state versus the permanent state, because nothing after startup, nothing in the game state changes, right? Like we generate all the rooms, we load all of our bitmaps, we create our collision. Are they entities when we create these? I think maybe they are. Oh, they're collision volumes, and they go in. They do go into the game state. So anyway, the point is all that stuff is permanent. Juggling lots of stuff here. There's lots going on. So yeah, I thought that was worth pointing out. But now that I think about it, I can kind of intuit why it would make sense. Again, you would only care if you wanted to do something semi-permanent with the memory again in between calls to begin and end temporary memory. But for right now, it always happens like at the beginning. Whenever we start that temporary memory, we're not ending it until the very end of the frame, right? Until the game has done everything it needs to do. So I think that all makes sense. So yeah. What do you think about this? An unfortunate bug is introduced where we are drawing the same bitmap over and over because we wait to draw. Yeah, so actually I ran into this bug twice. Casey runs into it himself, but only one time. Another time it's my fault, but we'll get to that at a later point in time. Probably not even today, I don't think, because none of the code that I'm going to talk about today has to do with the second time I ran into this bug. But the point is that pulling everything out into the render group stuff, let me think about this. Pulling everything out into the render group stuff means that it's being kind of, I don't want to say deferred because that implies deferred rendering, and I don't think that's what's going on here, but we are putting off like the actual drawing of all of these game elements. We're pushing them into the buffer, the push buffer, right? And then we want all of those things to be in there for us to sort later and scale and convert into different bases, rotate, translate, all that stuff, right? But because of the way that draw code was working, that's what it was. I think it was the temporary, it's not in here anymore, but a few weeks ago, we added the temporary, ground bitmap template, not temporary. I'm getting mixed up because I was just talking about temporary memory. There was this bitmap template that Casey introduces that every single ground buffer uses as a template, right, to then draw. But because we're not drawing it right away, it was winding up just drawing the same thing over and over and over. So now, instead of this just being, what was it? Yeah, so that's what it was. The ground buffer used to just store the memory where the texture would go, but now it stores the whole bitmap so that we do away with the whole template thing, right? So that's all that has to be changed to fix that. And yeah, you can see that right here in my notes. If I had bothered to read a little bit more, I would have seen that that's how things went down. Oh yeah, and then, so now we can talk about some of the new code here. So we allocate this render group, and this is where a pretty fundamental difference between Casey's implementation and mine shows up. It's actually nothing new compared to what has already been done thus far through the series, right? But Casey just uses a pointer. I can't remember if it's a void star or a U8. I just use a slice of bytes, right? Because wherever I see multi-pointer stuff happening, my instinct is to use slices now, if I can. And then we kind of give that render group things it needs to know, like the meters to pixels conversion. And then there's this render basis, which just has a position and is defaulted to 0. But depending on what we're adding to the render group, it may change. And if I look at some of this stuff here, in fact, I don't think there's anything. We're only calling that push render element call. Oh, I see. Push rect and push bitmap are still wrapping push piece here. Is that default basis being used for anything yet? Anything outside of? It kind of just looks like P is just always 0 for now. Yeah. So not doing anything interesting with it quite yet. Okay, yeah, so here I wrote in this note that the way that I have to get the memory out of each render entry to add it into the push buffer or render element. I think I call it an element here, but later on I call it a render entry. I'll show you what I mean. If I can make sure I'm in the right file. Push render element. I have to do this raw data thing, right? Because it is a slice. I have to index into it according to the size of the thing that's being pushed onto it. The reason why it's not hard-coded is because the idea is that we'll push things that have different structures to them that the renderer is going to care about onto the push buffer. Right now, it's always just going to be an entity piece, which has all these things, but not every single thing that we want to render is going to have all those things, right? Some of them are going to overlap, but a lot of them will have minute differences at least. Like a clear is just a color, right? You just want to draw one color versus like there's a bitmap to draw and there's a position on the screen that it's going to be in and all these other things. And I don't know if I'm using that. Yeah, I'm not doing this anywhere else, but in day 89, I started to have to do this more. And that's why I wound up going in a slightly even more different direction from Casey, which we'll see. But I think that's about it for day 88. But yeah, you can see the point of this note here is that I was kind of wondering if it just might make more sense to use a multi-pointer and store the size on the render group. I could totally get away with it because that's exactly what I did when I was working on this project in Zig, but I don't know. Just trying to see, I carried it forward to see in the best interest of seeing if I could just make slices work, and it turns out I can, but I had to sacrifice something. I had to sacrifice. We'll get to it in a little bit. It's a key reason why Casey does it the way he does it and why it's useful to do it the way he does it, but I wanted to see if I could do it. It's not even that it's necessarily the Odin way to do it, because it turns out he can do it pretty much the same way in C. It just looks a little bit different. It's more like I wanted to see if I understood what was going on well enough to be able to do it using just the Odin features that I had available to me versus using multi-pointers and whatnot. But we'll get there. And then let's see. Nothing too exciting going on in the Q&A. But you can kind of see here, he explained at one point, you know, the whole purpose of day 88 is to get everything that we want to draw for each frame into one group of things to render so that all the drawing will happen in one single loop. And then, you know, people were asking questions about how long the render was going to take, and he just says it's kind of up to how far he feels he needs to go to get the features he wants to where performance is not a concern, to like add more gameplay type stuff, right? And to be able to work on all these other things. And I think that's pretty much it. Yeah, let me see. I want to make sure I go down here and actually show where we allocate the render group using our our transient state arena that makes this temp allocator, but you can't forget we have this temporary render arena, right? And then do we do the push in here, push render? No, we do not. I see, yeah. So all of that is wrapped up in here when we call push bitmap. Calls push piece, which eventually in turn calls push render element, which adds to the push buffer, right? And then down here, we increment over the, yeah, this is actually what I was looking for a little while ago, but I didn't see it in the render group code, so I was like, where the hell did that code go? At the very end of the frame, right, when all of the other stuff that's been done to process entity movement or whatever has happened, we then iterate over the push buffer until we get to the limit of the actual amount, like the size of things that we pushed onto the push buffer, and then we stop drawing. But it's pretty naive at this point because all we do is check to see if it has a bitmap or not. And if it does, we draw a bitmap. If it doesn't, then we use the information in that entry to draw a rectangle. But that keeps it all isolated to right here, right? So that was something like the significance of doing that was probably completely lost to me last time, but this time I'm able to follow it, and I can even try and explain it, right? Albeit kind of poorly. So that brings us today. Well, actually, I should probably show that nothing, literally nothing has changed, right? If we build and run it, it'll just be exactly like it was before. We have our ground textures. We still have the seam in the bottom left, which is kind of annoying, but we can traverse the world, room after room, and those ground textures will keep popping in, right? It's just the difference is instead of drawing everything at different points in the program, we've thrown it all into a memory buffer that we can then sort all those things so that eventually, we will be drawing everything in the right order. Right now, like you can see, and Casey shows this a lot too, like walking around the trees sometimes for whatever reason, the hero is being drawn underneath those trees, which doesn't make sense because he's closer to the game camera, right? So that puts us in a position to be closer towards fixing stuff like that. Okay, so now we can fast forward to day 89. Take a look at the notes here. He kind of goes over the kind of reviews day 88 for a bit, right? And then talks about the different targets that we could write to, including OpenGL, a console API like a PlayStation or an Xbox, Direct3D, Vulkan, or a software renderer like what we're going to focus on for the time being, right? And that's really the point that he tries to drive home. I keep bumping into the mic. I'm sorry about that. He drives home this point that by isolating all of the game code and all the things that need to be drawn from each other so that all the drawing concerns are kind of isolated together, you kind of have everything in position to where you can write your rendering code to suit whatever target it is for a fact that you'll need to actually ship for, right? Rather than trying to come up with some generalized solution that's always going to work for all of them, you can specifically optimize for all of the ones out of this list, and it won't affect your game code. All the game code will be the same. It's just you'll have it all isolated in this render group with this push buffer, right? Optimize for different targets is exact. I didn't even read. Again, reading helps. I'm just kind of going off of memory, even though I have all this in front of me. It's just I can't stand to read my own notes because a lot of time I don't feel that they're that good. Yeah, and then he brings up the point of like, yeah, it's nice to be able to do everything, but you have to time box what you actually need to do to ship a thing to actually, ideally sell a game, right? Eventually. Yes, an intermediate representation is what he refers to it as, the push buffer. And he kind of points out that we can kind of think of it like that. It's a representation of all the things that we need to draw, and we'll have it well suited for whatever target that we care about, right? And then there's some other stuff in here that is probably not too important for me to dive too deep with. Wouldn't be the best use of anyone's time. Obviously, if you're following the series and you eventually get to this, and you're interested in rendering like I am, then you'll feel compelled to jot stuff down or go through the code multiple times. And for me, it's been pretty cool. I like seeing end to end. I can see where things are going and see where things have been coming from when I do things this way, right? The way I've been doing things with the new format, and it's clear to me that that's having some benefits. It really means some of this stuff is sticking, even though I might not be able to talk about it from memory or essentially off the cuff the way Casey can, right? But he's got all these decades of experience in games programming, whereas a lot of this stuff is still pretty new to me. And then I was wondering what Mantle was. I remember him mentioning it before, but he brings it up here and says that I guess Mantle was AMD's graphics API, but that project got dropped in favor of Vulkan, right? So Just thought that was interesting. I had forgotten. Maybe I'd never even heard of Mantle before. I can't remember. But Vulkan is the thing that I would like to be able to write a renderer for, right? That's kind of like a loose goal I have. It would be fun to, once we get to a point where we've got Handmade Hero working with OpenGL, I can then work through doing it with Vulkan and kind of devlog my progress on that. And then I think that would give me a pretty nice frame of reference, because it's one thing to do it for one target, write an implementation that supports that. To do it for two, I think, is going to make a lot of concepts that would otherwise fly over my head stick a lot better. So if we take a look at the render group code, we'll see the direction that I went in, which I'm still not sure is the right direction, but so far it's working out. And so I'm just going to stick with it until it fails me. So I have a note here that talks about this, right, where I thought maybe I'll just want this to be a multi-pointer and do it much more closely to how Casey does it, right, where we have the max size of it, which would essentially be the implicit length of a slice, right? And then we just have a multi-pointer of bytes. That would work because he does it, and I've done it before with Zig, so I know it has to work. And then, of course, here we denote exactly how much of that push buffer we're actually using thus far. So we know when to stop pulling things off of the push buffer to draw, right? So now we also have this union, and Casey does essentially the same thing, but to get this kind of union, which he calls a discriminated union, and this is what the Odin docs call an Odin union as well, right? It's called a discriminated union. It stores the types of the thing. Is that right? I actually can't remember if it does in Casey's code, but as you can see here in Odin, right, we have a union of a render entry clear, render entry bitmap, and render entry rectangle. Tentatively, Casey uses a header to denote the type of the thing to be drawn so that he can pull those first, I think it's like that first byte or those first 2 bytes out with the header, and then use that header to check the type. But I think he winds up moving towards just, storing the type at the top of the render entry, right? And then pulls those bytes off, and then he can just see, is this a clear operation or a rectangle or a bitmap? But I just used Odin's regular union. And I'm using this no-nil directive so that we don't have like a none type, right? Because we don't need it. We want to handle everything that a render group entry can possibly be, right? And so how does that help us? Well, if we come down here to this render group to target procedure call, which was the same code that was at the bottom of my game code at the end of day 88, right, as we just saw a little while ago. We pull that out, and now we have this neat little for loop where we can render over the entire push buffer, or sorry, not render, iterate over the entire push buffer and pull out each entry. And using just a simple switch case on the render entry, what is it, element? What did I call these? Yeah, it's just a render group entry, right? Just using a simple switch on that union, right? I just looked at Odin's overview to do this, and I thought, what the heck? Let's just go forward and try that out, and it works out pretty nicely. Now that code that kind of determines the entity's position to draw on the screen based off of its world position and all the stuff that gets stored in each of these render group entries. It's all encapsulated in this get render entity basis call, get render entity basis p call, and we don't have to do what we were doing before, which is iterating the base address, right? I wouldn't even call it a base address because it's not a multi-pointer, right? It would be iterating the index at which we are indexing into the render group push buffer to get at the next thing. Like, we want to correctly land on the base address for each entry, right? And to do that, we need to know the size of each thing, because each of these are a different size. And that's like the inherent disadvantage, right, of doing things this way. And Casey denotes his as being a compact, right, discriminated union, but mine is non-compact because I am not, I don't get that advantage, because we're going to use up all the space of whatever the biggest one is, right? The biggest of these types, which it looks like is going to be the bitmap, right? So it's just not as memory conscious. It's not as conservative with memory. And maybe it'll bite me trying to do things this way. I don't know. Casey said that it would be pretty important, but thus far it hasn't messed us up, right? It just means that I can't push as many things into my push buffer as Casey will be able to eventually. But I can always make it bigger, right? If I look at here. So this is another thing to keep in mind when going this route, right? Because it's not a slice of bytes or a multi-pointer of bytes, Casey uses 4 megabytes to allocate for the whole push buffer in the render group. And I wanted the same because I wanted to see, okay, if we're going to run into memory problems, then I should make sure I'm allocating the same amount of memory that Casey is for the push buffer, right? And so I just divided a megabyte by the size of one of these so that we know this is how many, this calculation, right, gives us how many render group entries we'll get from a whole megabyte, and then we multiply that by 4. So we still have the same capacity as Casey. It just means we're going to run out sooner because we're not being as particular about this. And, you know, if I wind up having to move back in that other direction, using a multi-pointer and then pulling out the base address, right, and then checking like a header or a type off of the top of each render entry, I don't think it'll be that bad, because we were kind of doing it in at the end of day 87, and it didn't look that bad. But here it's so neat, right? And I know I've seen, granted it was probably a very different, I think it had more to do with like handling different entity types and stuff, but I know I've seen Carl Zielinski, he's made a few videos where he uses unions to do really neat, easy handling of different types that have to have similar operations done to them, right? So it works in a similar way for him as it does for me here, and I like it a lot. I like how easy it was. There was nothing super difficult or complicated about it. And I think actually now if I just run we're gonna have the same exact end result, but I could be wrong. I'll run it here and see. Yeah, so nothing visually interesting to show, unfortunately. Oh, that was kind of weird. We had the background draw over the top. Well, I guess that kind of makes sense. The background, it just looks like it was drawing over the top of the ground texture briefly, but actually that doesn't make a whole lot of sense because we're not handling a clear yet. You see here I have this render entry clear type that we want to handle, but nothing is actually being done, and I don't think we're pushing anything of the sort onto the push buffer. And you know what? I think that's it. Let me check the notes here. There's a couple things being teased here, like a rasterizer, scaling and rotation. I'm still not totally sure what a rasterizer is, to be honest with you. Like, what about it is specifically, what about a rasterizer makes it a rasterizer? It's a big word. It's a big word for my small brain. Scaling and rotation is coming up pretty soon with bases, which is something that days 89 and 90 he talks quite a bit about. Let me see, was there anything I missed about the discriminated union stuff? I don't think so. Yeah. So really this is all it comes down to, right? I don't have to do as much bookkeeping as Casey does using the non-compact discriminated union. Yeah. So honestly, an easy couple days. It just took a little bit of thinking to make sure I didn't get the move to using Odin's unions completely wrong. And you can see here, I did change that call to push render entry from push render element. And the way that this has to work, that's right, that was one thing that I thought was probably worth talking about. So at the end of day 87, the size of the thing, the size is passed in directly to use to push onto the push buffer. But instead, I pass in the type, because I'm pretty sure that's what Casey does. He winds up defining a macro. But I just use some good old parametric polymorphism. Yeah. Thank you. It's okay. It'll warm me up. What is it? My blocking board. Yeah, go ahead. That is hot. A rasterizer is a technique that converts 3D models into 2D images for display on a computer screen, according to Google. Devil cheers you. But that's interesting because this is a 2D game, right? So I feel like that, sure, a rasterizer probably does that, but I feel like that can't be comprehensive, right? Fwishy? Is that how you pronounce it? Hey man, sorry to ask, were you a YouTuber at one point? You look super familiar and I don't remember following. Yeah, a long time ago, this channel's name was Clash. In fact, let's see here. Yeah, it's still the name of my machine somehow. I think that's just because I have a Microsoft account tied to that username, and I've never bothered to change it. Thank God you are here and you are coding now. Yeah, I mean, I never went completely away, and I certainly never announced that I was done. You know, I just kind of rode off into the sunset and did my own thing for a while. And I'm still doing my own thing, as you can see. So anyway, yeah, like I was saying, we were using parametric polymorphism to just pass in the type of the thing that we want to push onto the push buffer. And because it's the same size, we don't need to worry about, you know, the size that we're allocating off of this push buffer. But one thing that I do have to do, right, is I have to dereference the render group entry at that index to make sure that it is the right type, right? Because otherwise, and I think if I just uncomment this, we'll get a compile error, so you can see, or maybe it'll be a runtime error. Yeah, runtime error. Invalid type assertion from render group entry to render entry bitmap, right? So because I didn't explicitly say, hey, at this address, you know, dereferencing the thing at this address, because this is a pointer, right? And because I commented that out saying that this is the type that I want you to be, which is whatever type that gets pushed in here, whether it's a render group bitmap or rectangle or a clear command. I think there's one more thing. Well, yeah, once Casey gets into coordinate systems, we had a render group coordinate system or whatever. So we have to denote it there, and that's like the one extra thing that you have to do going with Odin's unions. Whereas if you just went off of the memory that's there, right, and you pulled out the first byte or whatever and said, okay, at the base address here, are you a rectangle, or are you a bitmap? What kind of draw operation do you want me to do here? And then instead of incrementing the push buffer size by the size of the thing that we are adding to the push buffer, we just increment it by 1, because it's always going to be, you know, an index of 1, because it's no longer is this bytes, right? It's one of these. It's always going to be a render group entry, which then corresponds to one of our actual types that we want to draw. So it's not too complicated. Odin makes it easy, and I like it so far. But like I said, I have this note in here. I might have to walk it back, but I want to see, part of the benefit of doing this is that if this decision bites me in the butt and I need to go this way, I'll be able to see exactly what kind of problems I run into. But so far, it just has made things easier. It's less error prone, right? Proud of you, dude. Thank you for all the good times. You are very welcome. Thank you for being here. Rasterization also applies to 2D shapes. It's just a process to convert geometry to images regardless of dimensionality. Okay, that seems intuitive enough. You have a bunch of data about shapes, right? Whatever they may be, bitmaps, rectangles, triangles, any kind of geometry. And you want to convert that into images. Right. I.e. a rectangle shape turning into a block of X by Y pixels on the screen. Totally. I mean, it kind of feels like we have something approximating a rasterizer at this point then, to me. You know what I mean? It's just like how fully featured does a rasterizer need to be to officially be a rasterizer, I guess is my question. Let's see. I have some notes in here about an implicit surface rasterizer. Instead of walking which pixels we want to fill, we get a rough approximation of those pixels on a boundary. So like just taking like subsections out of the whole buffer that we want to render to, determine which 4x4 pixels it might touch, and evaluate every pixel inside of there. So it's like just doing like a cover all my bases type of thing instead of, trying to be clever about knowing which pixels to draw to or something like that. Yeah, we'll work up to the rasterizer with rectangles because we use sprites and don't need many triangles for this game. See, a good challenge for me would be to do it with triangles, right? Because that would give me something more to think of, and then like I feel like I should be thinking in terms of triangles because that's what, everything is triangles, ain't it? So, like for 3D, it would have to be. We couldn't do rectangles for 3D, or maybe we could, but it would be constrained, very constrained. I don't know. A lot of that is still pretty far outside my depth, but yeah, that's really all I had. And somehow it's already been almost an hour. Where does the time go? So yeah, that's where we're at. What's going on here? That's right. Going into day 90, where Casey pivots to talking about coordinate systems, and then we add that on to the push buffer. So it's a lot of rendering stuff from this point forward until I think somewhere in the mid 100s we start doing more optimization stuff because the game slows down quite a bit. I guess one thing that I'll show off just as an observation, because I thought it was neat, because at this point, actually it's more interesting later when we add, like we start drawing the rooms into the screen again and start drawing staircases and things like that again, and then also adding the grid to show where all of the ground chunks are in the world. The game runs pretty smooth. In fact, even here you can't see the different ground chunks being evicted and then being drawn in as we traverse the world. It just kind of all runs nice and smooth. Even on my MacBook, if I'm compiling with optimizations, it works pretty well. And obviously, it's not like this is a super intense game graphically. It's not even a game yet, right? But we have like a kind of showcase here now. But the fact that it's all using software rendering is just kind of fun. There are quad primitives in 3D modeling. Right. Like, so not just... yeah, well, that makes sense because, yeah, everything may be triangles, but you don't always need to use triangles. And, well, I guess quadrilaterals could be made up of triangles. Could they not? Anyway, it's fun because it's more visual, right? Like that's the stuff that I think is more interesting to show off too, is when you can do interesting things visually, which is what's going to happen more and more here pretty soon, before things get probably really kind of dull again and wind up being more about like debugging and logging and I don't know. People get really excited about UI stuff like adding fonts and menus and stuff like that, but that sort of stuff actually isn't very interesting to me personally. So there's something for everybody. But yeah, that's it for Odinmade Hero today. Thanks for hanging out with me again for another stream. I'll be back as usual until further notice anyway next Friday, where we'll start talking about coordinate systems, and we'll get to do just more fun rendering stuff. Just keep on expanding on this very simple renderer that we have thus far, and doing it with Odin. It feels good. Still nothing so show-stopping and upsetting that has made me want to change languages. And at this point, if I was upset enough to change languages, I might as well just give up. You know what I mean? Because Odin makes it that easy for me. You can make a quad with 2 triangles, but it depends on what you're doing. Making a square requires 2 triangles, which is storing 6 points, while a quad would only need 4. I see. Yeah, that makes a lot of sense. So it's all situational, right? As is often the case. But if you were going to do, like, for instance, like drawing a box, a simple box in the game, you wouldn't want to abuse triangles for that. But that's just a very naive take, I'm sure. So anyway, yeah, have a good weekend wherever you are. Thanks again for tuning in, and I'll see you in the next stream. Take care.